Good morning, dear students. Hope you are all fine and enjoying your online studies. This is week 1, session 2, second video of May month. In our previous video, we have discussed about zeros of polynomials, and in this video, we are going to discuss about geometrical meaning of the zeros of a polynomial. In this session, we will learn to draw graph of different polynomials. For a linear polynomial, the graph will be a straight line. In general, for a linear polynomial ax plus b, where a is not equal to 0, the graph of y equal to ax plus b is a straight line, where x is a point on x-axis and y is a point on y-axis, which intersects the x-axis at exactly one point, namely minus b upon a comma 0. On x-axis, we get value of x coordinate minus b upon a by equating ax plus b equal to 0. When ax plus b equal to 0, we get x equal to minus b upon a here. And value of y is 0 here. Therefore, the linear polynomial ax plus b, where a not equal to 0, has exactly 1 0. Namely, the x coordinate of the point where the graph of y equal to ax plus b intersect the x-axis means here minus b upon a is 0 of the given polynomial and it will considered as the x coordinate of the point. Let us take an example. The graph of y equal to 2x minus 3 is a straight line. Why? Because it is a linear equation, it is a linear polynomial in one variable. And the graph is passing through point 0 comma minus 3 and 3 by 2 comma 0. Now let's see this graph looks like this. This is a straight line which we obtain from the graph. And how this line is obtained? In the given equation, when we put x equal to 0, we get value of y equal to minus 3. On putting x is 0, this value becomes 0 and we get minus 3 here. So the value of x equal to 0 and y equal to minus 3. 0 comma minus 3 will become a coordinate on this graph. Again, for value of x 3 upon 2, we get value of y equal to 0. When we put value of x 3 upon 2 here, we get value of this polynomial equal to 0, that is y equal to 0. This is another coordinate. So we get two different coordinates here, two different points through which we pass a straight line which gives the graph of the required equation. This is a line which passes through these two coordinates and this will give a straight line. What is written here? Here the graph of y equal to 2x minus 3 is a straight line which intersects the x-axis at exactly one point, namely 3 upon 2 comma 0. Second, for quadratic polynomial, we will not get a straight line. For a quadratic polynomial, ax square plus bx plus c, where a not equal to 0, the graph of the corresponding equation y equal to ax square plus bx plus c has one of the two shapes, either open upwards like curve or open downwards like curve 2. This is curve 1, this is curve 2. Depending on whether a is greater than 0 or a is less than 0. Different values, when we put different values of x and y, we will get different coordinates, and from those coordinates, when we draw a graph, these graphs will look like this. Like curve, depending on whether a is greater than 0 or a is less than 0. These curves are called parabolas. These curves are called parabolas. Case 1. The graph cuts x-axis at two distinct points. We can see that second. The x-coordinate of the quadratic polynomial ax square plus bx plus c have two zeros in this case. In which case? When the graph cuts x-axis at two distinct points. This indicates that the number of times the graph cuts the x-axis, it will give zeros equal to those numbers. Now, let's see another graph. The graph cuts x-axis at exactly one point. This is the point where the graph cuts x-axis, either open upwards or open downwards. We see this point here. So, the x-coordinate of the quadratic polynomial ax square plus bx plus c here have only 1 0. Here the graph is completely above x-axis, means it is not touching the x-axis, either open upward or open downwards. So in this case, this quadratic polynomial have no zero. From this graph we can see that it cuts 1, 2, 3 and 4. It cuts x-axis 4 times. So this graph or this polynomial will have 4 zeros in it.